Trig functions are often called circular functions because of their relation to a point traveling around a unit circle. So recall our unit circle here, and if we put a little triangle in here, we know that we have, and if this is a unit circle, our radius, the hypotenuse of the triangle, is 1, and then the two legs are our x and y coordinates. And as this point travels around the circle, those x and y coordinates, those x and y directions, those two legs of the triangle are constantly changing, and as they change, they cause our sine and cosine values to change. So we're going to focus one at a time on first the adjacent side, the x value, and then the opposite side, the y value, and we're going to see how the changes in those sides of the triangle are used to create the sine and cosine graph. So let's start with cosine. Cosine is the x direction of a triangle. So we're going to look at something on Desmos here, and we're going to notice here that this red line, this red horizontal line, is the adjacent side of the triangle, which isn't actually a triangle right now. So let me kind of move this up a little bit here. So we have this triangle. Here's the adjacent side. And right now we're at 0, and we're at the longest possible adjacent side. In a unit circle, then this adjacent side would be 1. Now what I want you to notice here is we have an x-y axis. So here's the x-axis, here's the y-axis, and this y-axis represents the length of that adjacent side, which is the cosine value. Right now it's 1, so we have this length up here. This is 1. Now as we move from 0 to 90 degrees, the adjacent side is decreasing. So we see here the adjacent side of the triangle is decreasing, and this y-coordinate, which is the cosine value, is also decreasing. As we get up to 90 degrees now, we see the adjacent side is now 0. So we're at 0 on our y-axis on our graph here. The x-axis, of course, represents the angle here as we're going around the circle. So as we continue to move around the circle, now we're in quadrant 2 where the adjacent side is negative. So notice my y value here, which represents the length of the adjacent side, is negative. As we go around to 180, we reach -1, the lowest part of the graph. Now as we move into quadrant 3, we're still negative, but the adjacent side is getting smaller and closer to 0, which we hit at 270. Now once we get into quadrant 4, the adjacent side is now positive. And this little thing is there. Kind of shift that over. There we go. Now let's take a look at, let's put this on paper now on our notes. Okay, so on our notes, we started out with the adjacent side at 0 being equal to 1. So on our graph here, that would be this point right here, 1 in the y direction. Now we know that the cosine values are positive in quadrants 1 and 4 because the adjacent side is positive. And they are negative in quadrants 2 and 3 because the adjacent side is negative. So we're at -1 at 180. So I'm going to put that point down here, -1. And then when we get back around to 360, we're back up to +1. So I'll put that back up here. Now notice that when we move from positive to negative or negative to positive, then cosine ends up being 0. So at 90 and at 270, we're 0. Now what happens in between? Well, as we move from 0 to 90 degrees, the cosine value, or the adjacent side at each point, the x direction, gets smaller and smaller. So what we see happening, and actually I meant to make those all blue, and I think I will make those all blue because I want to color coordinate this the way I meant to do. Okay, so these are all blue. All right, so we're going the positive direction but getting smaller. So we see the graph going down, and we see these are the lengths of that adjacent side. These are the lengths in the x direction as we are at different angles. So as we move around, and maybe we're now at 45 degrees, we have a shorter adjacent side, which is a shorter cosine value than we had before. Now as we get into quadrant 2, now we are going in the negative direction, and we're seeing increasingly large values in the negative direction. So this corresponds to going from 0 to 180 on our cosine graph and seeing larger and larger negative y values, with the largest being at negative 180 when we get down to negative 1. Then we're into quadrant, so here's a negative sign here, we're into quadrant 3 now, and we're seeing our cosine values, or our y, or our x values, getting shorter but still negative. So we're going back up to where we end up at 0 again. Once we cross over into quadrant 4, we're seeing as we move around the circle these cosine values getting larger again until we're back up to 360 and we're back to where we started from. So this is the shape of a cosine graph. The x value on this graph are angles. We see the angles on the x-axis. The y-axis represents the trig value, in this case the cosine value at each angle. So the angle, for example, if I was at a 45-degree angle, then I would have an x-coordinate and a y-coordinate here, and this x-coordinate, this distance in the x direction, which I could also write from here to here, which is the same distance as from here to here, that distance is the cosine value in a unit circle. So this is a unit circle. We talked about a unit circle, so the radius, or the hypotenuse, equals 1. So remember we talked about x, if cosine is x over 1, then cosine is just the x value of each point. Now to help you remember the cosine, then I came up with kind of a corny little saying here. So here's the basic shape of a cosine graph. Looks like that. So I thought of this as cosine is a cup that starts up. Okay, starts up, it ends up, and it has a cup shape to it. To summarize, cosine describes the x-coordinate of a point traveling around the unit circle, or the length of the horizontal leg of the triangle formed by the reference angle. And that horizontal leg is the adjacent side of the triangle. Now let's look at sine. Sine is very similar, and it's actually a little easier to see, because right here in cosine, we're looking at a horizontal distance on the unit circle, but that horizontal distance is being represented as the y-coordinate, which is vertical, on the graph. But now we're going to be looking at two vertical distances. It's a little easier to see. So if we look at sine here, so sine, we have our unit circle, and notice now when we're starting at 0 degrees, the vertical side, or the opposite side, is 0. It's not there. So we're starting, the height is actually 0. Now as we move around the unit circle, notice that as we move from 0 to 90, the opposite side gets to its very peak at 90, and it's tall. Okay, it's at 1. It's still positive, but getting smaller when we're in quadrant 2. So now, then we're down to 0 at 180. And then we go into negative y values in quadrant 3 and 4, getting down to negative 1 at 270, and then back up to 1 at 360. So notice that these vertical distances on the unit circle correspond exactly to vertical distances on the sine graph. So this is actually a little easier to see. So we start out at 0, sine is equal to 0. As we move around, we have sine being positive both in quadrants 1 and 2, so we're at a positive 1 at 90. Back down to 0 at 180, because then we move into negative values in quadrants 3 and 4, reaching a low of negative 1 at 270. And then back up to 0 at 360. Now, as we're looking at the vertical side of the triangle now, so we start out with 0, our vertical side being 0, and our vertical side is increasing as we go up to 90, and then decreasing as we go back to 180. So we see increasing, decreasing values in the vertical direction. Then we go to quadrant 3, and our sine values, or our vertical side, is now negative, and it goes down to a low of -1 and then comes back up again. So this is very straightforward. It looks exactly on the graph like it looks in the unit circle. We're looking at vertical distances both places. So in this case, x represents the angle again, and y represents the sine value at that angle. To help you remember the basic shape of a sine graph, which starts at 0, starts at the origin, curves up, curves down, and then back to the x-axis, I like to think of this as sine is a snake. It comes up out of its little hole in the ground at the origin, and it slithers around the x-axis. So hopefully cosine is a cup and sine is a snake will help you remember where it starts and what the basic shape of the graph is. Now sine describes the y-coordinate of a point traveling around the unit circle, or the length of the vertical leg of the triangle formed by the reference angle. That would be the opposite side of the triangle in relationship to the angle. Now in the next 2 videos we're going to dig in deeper about some more specific points that are on the cosine and sine graphs.